Hello, my name is Amy Morgan and I'm here to introduce the MICROGen, our rapid control prototyping system and CAN gateway. Today I'm going to be showing you how easy it is to build a model to interact with the MICROGen hardware. In this video we'll be creating a simple model to control the LEDs on the MICROGen. Let's get started. We're going to create a model that interacts with the MICROGen's hardware, controlling its LEDs. The first step in creating a model for MICROGen is to open up the MICROGen Simulink target support package FlexiTarget. It fully utilises the speed and features included with MATLAB Simulink, making model creation an easy process. FlexiTarget is used as the support package for MICROGen and is also a generic target that allows control models to interface with a wide range of alternate hardware. To construct our model, first we'll need to place the appropriate FlexiTarget configuration blocks, the target configuration and the Visual Connect CCP block. These configure the model for use with the MICROGen hardware and control how it will communicate over CAN. Next, we can introduce function blocks. For now, we'll just drag in the LED block. We can set the conditions such as the sample times for these function blocks, which dictates how often they execute. You'll notice instructions within the dialog box which allows you to configure your parameter blocks. Parameter blocks define values for the function blocks we've already placed. They operate as the vehicle to feed information into the model from instructions issued from the outside. In this case, this will be a GUI created in Visual Connect. We'll go ahead and drag that in a parameter box for the LEDs. This must then be renamed and configured appropriately. The LEDs function in an on-off manner, so we'll simply set off to 0 and on to 1. We'll have to put these in a vector of 10 Boolean values representing the states of the LEDs. A simple debug operation can now be performed by pressing Ctrl D, which will refresh our model and flag up any errors. As you can see, when it's completed, the blocks change colour, indicating different sample rates. Once this is complete, we can hit Ctrl B to build our model. This is now compiled and ready for use. We will now create a simple GUI with Visual Connect to interact with and control the MICROGen's LEDs. Firstly, we'll create a blank form which will be the canvas for our interface. Next, we'll open the connection to the MICROGen through the Connections drop-down on the right. We'll use MICROGen over CAN and tell Visual Connect we're using the COM dongle CAN interface. We'll now select our model so Visual Connect can pull the parameters and signals in for us to use. Now in the Connections window, you'll be able to see the LED parameters and signal blocks from the model, which will be our connections. Now we can start creating the interface itself. From the connections, you can see our LED parameter we made earlier. We'll drag in a multi-LED control and configure this to represent the 10 LEDs on the front of the MICROGen. We'll tell it that there are 10 LEDs and then link the LED value parameter we made earlier. Now that our interface is complete, we need to download the model from the PC to the MICROGen via CCP. If we go to the Connections menu, then click Download, we get the download window. We'll target the MICROGen's flash memory and go ahead and find our model. Once selected, it's ready to download. This process only takes a matter of seconds. This allows engineers to make changes to models and implement them quickly, reducing development time. The MICROGen will now reboot and have the model stored inside. To interact with the model using our GUI, we'll hit Run on Visual Connect. We now have control over the interface and therefore each individual LED. By clicking each virtual LED in turn, you can see the corresponding LEDs on the MICROGen turn on and off, depending on the settings in Visual Connect. So within a couple of minutes, we've put together a basic model, downloaded it to the MICROGen, and used it to control some real-world hardware. With the aid of a suitably complex model, the MICROGen can be used as a prototype electronic control module within a prototype vehicle or lab car. Thank you very much for taking the time to watch this video today, and please join us for our next one where we'll be looking at the MICROGen range in more detail.